Hey guys, Zal here, and if you're like me, you may wake up one day and think about how batteries are in absolutely everything. From phones to laptops to even electric vehicles, batteries are kind of the basis of all modern wireless electronics. And if you're also like me, you might be looking through your phone one day and notice this screen. That's right, maximum capacity at 81%. So why does this happen? Why are these batteries that are supposedly rechargeable and economical and environmentally friendly degrade? Why do we have to keep getting new batteries in our phones? How come if I use my phone each year, I kind of start losing battery capacity and have to eventually get a new phone or replace my battery? Well, it turns out this is actual simple chemistry, and that's what I want to go over today. I'm going to talk a bit about lithium-ion batteries and kind of the chemistry behind how all these batteries in our modern electronics work, and let's hop right into it. Now, to understand why lithium-ion batteries and all our electronics degrade, we first need to understand the basic principles and chemistry behind them. Now, this is what's called a secondary electrochemical cell. And what that basically means is it's a rechargeable battery. And there's multiple different types of rechargeable batteries. There's also nickel, cadmium, lead acid, etc. Today we're going to focus on lithium ion because that's the most charge dense and what we see in all our electronics and electric vehicles and all the likes of those. And that is because lithium ion is the most charge dense type of battery. The downside to this is stuff like a lead acid battery, which you see in car batteries, has a lot more lifespan to it and won't degrade as fast. Well, with this lithium ion battery, these all work on the same basic principles. You have an anode here in red and a cathode in green. And what happens is in between, these are sitting in what's usually a solid polymer electrolyte. And that just allows these lithium ions to flow between each side with a separator in the middle to, regulate the ion flow between each side and only let these ions through. So what happens in this cell is you have lithium ions crossing over from the anode side to the battery to the cathode side of the battery. And what that does is actually discharge electrons through the battery up here, and you can plug anything into this, a light bulb, a car, whatever, and you'll get electricity flowing through it. And the wonderful thing about a secondary electrochemical cell is you can also pump electricity back in because this is all running off a simple reversible redox reaction. So what happens is when you pump electricity in, you have the electrons flowing in the opposite direction and you get your lithium ions crossing back over to the anode. Now, generally, these anodes are made out of graphite with lithium ions interspersed in, and this is a cathode made out of a lithium cobalt complex. When you hear about in the news that electric vehicles need a lot of cobalt mined, and that's where it goes. All the cobalt for these lithium ion batteries is going into your lithium cobalt complex cathode. So if this is all a simple reversible redox reaction and you can get electrons out and pump them back in over and over, how come you get a falling battery health and you don't get as much capacity out of an older lithium-ion battery than a newer lithium-ion battery? Well, it turns out this is actually a sort of complex topic, and there's actually multiple little side reactions that can go off in a simple electrochemical cell that'll cause battery health to slowly degrade over time. Now, the first thing I want to talk about, and probably the most relevant to battery health, is what's called SEI layer formation. And what that stands for is solid electrolyte interphase. And what that basically means is you have this electrolyte filling this area between the anode and the cathode that's allowing these lithium ions to flow back and forth. And what happens is you get a solid formation of electrolyte forming around your anode. Now, this actually occurs around the first charging of this battery and can decrease the potential battery health by around 10%. This isn't really something that can be avoided, but over time, this layer can grow even more and keep degrading your battery health. The issue with this SEI layer that forms around your anode is as you get more and more layer formation, what's happening is you're trapping these lithium ions inside that SEI layer, and they can no longer be used in this transfer process between the anode and the cathode. And what that does is, of course, it's lowering your battery health a bit, and so over time, as you have this layer growth, you're going to lower your battery potential. Now, why does this layer form? Well, there's a couple of reasons, and one of them is high temperature and the other is excess voltage. And so over time, any kind of displays of these extreme temperatures or currents can cause slight SEI layer growth. And even without these, you're going to have slight growth over time, slowly diminishing your battery health. Now, the second thing that can diminish your battery health in your cars, phones, and laptops is actually lithium plating. And this is also caused by similar things to SEI layer formation with over voltage and temperature when you're charging your cells. And basically what happens is you're pulling these lithium ions out of solution and creating a metallic lithium layer on your anode. What that's going to do is you're going to cause higher anode resistance on your anode, and at the same time you're again pulling lithium ions out of your electrolyte, and they can no longer be used for this electricity transfer between anode and cathode, and you're going to diminish battery health. Now, we've talked about a lot of issues that can happen in the anode, and so next I want to talk about issues that can happen in the cathode to decrease performance, because there's a lot of stuff revolving around positive electrode decomposition that can totally decrease your performance of your battery. The first one I want to talk about is simple disordering. And as mentioned earlier, this is a transition metal complex of cobalt that's used for the cathode. And so what this means is these lithium ions in solution can swap out with metal ions in the cathode, and now you have transition metal ions in solution. What this means is you're going to have less of these lithium ions flowing through your electrolyte, and you're going to decrease battery performance because you have less ion flow between the two sides. Now, the second thing that can happen with positive electrode decomposition is if there's any moisture presence that makes its way into the battery. Because of the makeup of a lot of the chemicals used in the battery, mixing with water can actually create acids in the battery. And what these acids do is they are going to attack your cathode. And what that's going to do is it's going to bring transition metal ions from the cathode into solution. And just like with disordering, now that you have transition metal ions in solution instead of lithium ions, you're going to be able to decrease your battery's performance over time. Lastly, the lithium cobalt oxide of the cathode can actually lose oxygen atoms from its lattice. And what this does is it causes the transition metal dissolution into the electrolyte. As we've mentioned multiple times before, this will decrease battery performance. But what this can also do is cause a rock salt formation. And this is like the SEI layer and the anode, but you're basically going to form a layer around your cathode that might catch lithium ions in it and kind of increase resistivity of this electrode. And all of these things together on the positive electrode can lead to a lot of decay of battery performance. So that's a lot of the basic chemistry around a secondary electrochemical cell, otherwise known as a rechargeable battery, in this case lithium ion. A lot of this chemistry working together at the same time over time is what leads to a lot of battery health degradation in your phone, laptop, or electric vehicle. Now, I hope this shed some light on stuff you didn't know about battery health in your phone, and be sure to like the video, and I'll see you guys next time.